Hey there, welcome to the install video for Stable Diffusion. We're going to follow along on my website's page, Hallett Visual / AI Startup, or on the menu it's Getting Started with AI. With AI we really mean Stable Diffusion in this case, and the complementary software that interface with it called Automatic 1111. So to get started, we need to first install Python 3.10.6, and we'll use this to compile the code that we're about to download. So go to Python 3.10.6. Do not use a more recent version as much as you're tempted to. You will not get faster or better results. It just simply won't work. So go to Windows Installer, 64-bit, 3.10.6. Now, I've already installed it, so you will say install and then default. And importantly, you want this to be checked. It should be default checked, but add Python to environmental variables. If you have problems later and you can't find Python, this is the problem. So you can manually add it later into your environmental variable pathways. If you have trouble with that, Google it or just email me. Next, we need to install Git for Windows. I'll explain what that is while we install it. So we click on the link, Git for Windows right here, 64-bit setup, small program. And this will allow us to transfer, download, and the language they use is clone repositories from GitHub. And if you've seen GitHub, all defaults, by the way. And importantly, we want git, the command line. That's very important. So again, that's the default, but make sure that's checked and just go through the rest. I've already installed it, so it's reinstalling it. So this will allow us to clone repositories from GitHub, which means if we go to GitHub, oh, well, I've searched it recently, so the default's coming up with Automatic 1111, which is what we're installing. And the install instructions that I'm following are here. And so once you do this a couple times, you might feel that you might feel comfortable then exploring some of the GitHub offerings. And if you start diving into the research of machine learning and Stable Diffusion and Codeformer and some of the other amazing stuff that's coming out every day, a lot of those will be links to GitHub. And so if you keep scrolling down on the pages, you'll find you can skip this part. That's for Linux, for the Windows. So we're going to actually end up copying this code. We'll copy it from my website just because there's a few other commands before we do that. So, but this is what we're using. Okay, so going back to the page, we have to now open a command prompt. Oh, we've done that. Click the review notes. Done. So we're going to open a command prompt by typing in command. And my username on my PC is MRH. So you'll have another name, but when you open command prompt, it'll be likely 2 directories past cprompt. So CD stands for change directory, and ... means to go back. So CD space ... CD space ... And now we're in just a typical command prompt, but we are going to have, now that we have Git installed, we can copy this code right here. Command, I guess is the right word. And paste it. Control C, Control V, enter. And so the reason we want to do this in our root directory of C is that, one, with this type of performance software, we're going to want to definitely use our SSD drive on our root. But also the root directory, when you clone, it'll make a directory automatically called Stable Diffusion -web UI. So CD again for change directory, Now, if you don't know some of the how to use these prompts, commands, or whatever they're called, it's from a certain generation. Before we had Windows, we had DOS, and so this is basically DOS. All right, so we cd into that directory, and now we're going to run Stable Diffusion for the first time. And that command is here, web UI-user.bat. So Command C, Command V back on our command prompt. I hope there's not too many text on the screen here, depending on your resolution. Enter. And so when we run it the first time, Git is going to pull all the code, programs, files, everything we need from GitHub and Hugging Face and PyTorch and stuff that just all will run in the background, and it'll fill up for the most part, it's all going to load onto our C/Stable Diffusion web UI. And so once this is done, yes, you can change that long directory to something a little more simple, which I've done on my C, and press the middle button. So if we go on to my C, you can see we've created this new directory. My regular working directory, when it's not a tutorial, I've renamed it to SD. And so I have all my models, and I'll explain that in a second. All right, so this is now what's being created and compiled. So I'm going to move that aside. And so here is what you should be seeing, the cloning of the repository from GitHub. There shouldn't be any errors. This won't take too long, except depending on your internet speed, you will have to wait for the one default model to install. And a model file is about they're like 2 to 8 gigabyte single files that contain all the imagery that was pulled and scraped from the web to make it's the database of imagery that we use when we start using prompts to generate the AI art. Okay, so I'll go return to my website here, and we've installed that and it's running for the first time. So once it runs for the first time and installs, we were going to go back to, let's go to our here, and it's already copied. So while this is downloading, you should see this, there's still requirements being installed, and we still haven't yet got to the big file that has to be transferred, which is now, this is the default. It used to be called a checkpoint. Now they're called safe tensors. Checkpoints, if anybody's familiar so far with this, is that they apparently could hold malicious code. And so they're almost the exact same thing. I haven't noticed any speed difference when generating images, but apparently safe tensors are the new standard for model checkpoints. Okay, so while that transfers, we need to edit our web UI user batch file. Batch file is a simple text file that will just have a bunch of prefix codes that we can put in. And what all of these, okay, so API we're going to need later to interface, especially if you want to try the Photoshop plugin that's free for Stable Diffusion. No half has to do with certain models that I was experimenting with, but I believe that's something you have to put in there all the time now. And it has to do something with float values. And I cannot remember why I put disable nan check, but it doesn't seem to do anything, so I just kept it in there. So you can copy all of this, which is a duplicate here, except for also the addition of git pull, which will update Stable Diffusion and automatic 1111 every time you run this file. So we're going to copy that here and just replace it. and update it. And I have a little, this code is different than the one on the screenshot. It just tells you what this is for. It doesn't matter. When you put a hashtag, they used to be called pound signs. So you put that there, that means that this is whatever you put in front of it, after it, it won't be read. And so it's just ignored, and they're like notes. Okay, so save, close. We're coming back. Still haven't installed it. I'll pause the video there. Okay, so my download's almost complete. And so in the meantime, we'll go to step 5, and we'll also download the next model that would require, that will go in this directory here. I'll explain that in a minute. So we're going to go to either two websites. I need to correct the link on that. All right, so we're going to go to either Civet AI, which I'm going to command paste into the directory here, or we're going to also download from here. Both of these contain free models that we're going to use for the generation of art, and the one we want now, let's download it from Civet. Civet. This is the page. I've copied the direct link over to Deliberate, so we'll go into that right now. Is that you need to download version 2, and scroll down here to version 1.1 and download that as well. Most of the testing and some of the best results I've had are from the Deliberate 1.1, this model version here. Now, it's not, obviously, none of this is architecture, except for the waffles, which, there's a little bit here. No matter, there's, for whatever reason, this model so far has some of the best results. You can absolutely explore with all the models that are available on Civet AI. Since we're focused on doing all of the stuff that's not this, you have to scroll through and find the models that you think might work, and usually they're kind of in the title here. And so every day you check it, it's just more and more of anime or whatever this is. This one's pretty decent, but you have to use the specific resolution. So again, we'll get more into that later. Huggy Face, for those not familiar, is works in conjunction with GitHub and hosts a lot of the big files that you require. It's also where you can find all the latest AI, machine learning. I mean, it's the AI community building the future. I mean, it's right. It says it right there in the title. All right, going back to that we install. We're downloading Deliberate. Pardon me. We're downloading Deliberate into our folder, which is under our new directory, which you can rename now at any time once everything is complete. Once this is all done and you see the URL pop up, you can close this and rename this directory if you want, or move it to a different directory. So if it's in users, you can move it now to anywhere you want. So we're going to go to Models, Stable Diffusion, and the default that was downloaded is our pruned EMA only safe tensor. Every time you go if you're watching this a week from now in April, then it's perhaps the latest 2.1 that may be installed as default. So we copy that over into or save it directly into our Stable Diffusion /models/Stable Diffusion, and then we return back to the root directory and click on our edit it. Let me just check to make sure that this has the correct code that we want. And now we just double click the web UI. And so this will run the command prompt again and run for the second time, so we don't have to download anything. It'll check to see if it's up to date, already up to date here. And then it's going to load into the extensions and all the stuff that you've done. And while there it is. So copy this URL into a new tab, and you can see that we have a more recent safe tensor checkpoint model. It'll appear as the default. So right here are our checkpoints. So that's the default, and that's the other one, or that's the deliberate that we're going to use. If you download a new one, hit refresh. And so the first thing you want to do, once you get this thing ready, and this thing pops up, that's good. That means so far everything's working, is that we're going to type in our first prompt. And this is text to image generation. Right here, text to image. So we're going to say a house on a hill in front of a lake with a pool at night. Aurora Borealis. No, just Aurora. Let's see what happens. Leave everything default. Now, this is a model trained, excuse the language, I'm trying to pick the words carefully so that I don't use anything I haven't used before, but the defaults are 512 by 512 always. And the next set of training models were done at the resolution of 768 by 768. So we'll start with this 768 by 768 because you'll get solid results. And depending on the resolution, you'll see the results can be completely messed up. The Aurora worked. All right. Now, one of the comments was that is it like rolling? It's a slot machine. Every time you hit generate, you're going to get truly, literally a random number. This is literally a random seed. So the only way to replicate the randomness, to cease the randomness, is to put a seed in here. So if we click this, -1 means random. And so if we have a fixed seed, then every time we hit generate, we will have a consistent result. And so when you're experimenting, you may want to hold the seed at fixed value and then make the adjustments while we're learning in our steps. So sampling steps will, just as you probably think they're going to add more information to the calculation. However, once you go to a certain tipping point, then the image can almost morph into something completely different. It's not always directly resulting in better quality. There's like a value that you kind of need to, like a range that you need to stick to in order to get consistent results depending on the sampler that you're using. And the sampler is a whole different thing. So if we go back to 20, which is the default, and because we have our seed fixed, we'll get that original house. This is the one that we just had. Not the very first one, the one where I fixed the seed. And so there's a few pages online and you can type in, what do sampling methods mean? What do sampling steps change? And people have made big, like, full page matrix to show you the steps that well, I'll go into sampling methods, but the steps, the fact that the image changes so much through the steps is part of the thing that makes this kind of so frustrating. You end up just using a fixed value between 20 and 50. And then when you're using the two methods you want to stick with for now, sampling methods, are Euler A, and one of the latest is the DPM, SDE, and Keras. Already today, that's a new one. UniPC, never seen it. It probably won't work with this model. So I hit generate. Curious. This is all evolving in real time. It doesn't work. So that's a perfect example of when it doesn't work. And that can be a combination that this model, or this check, well, here it's called checkpoint. The safe tensor model. Oh, look at that. Wow. Oh, wow. That's amazing. That's like, the samplings are so high. Oh, it looked like garbage. I didn't think it was going to turn out. I don't know if I should keep this in the video or not. Yeah, so every day, right? I mean, truly experimenting. The CFG scale means that you are playing around with how intense the stable diffusion is paying attention to these words, right? So 2 means, like, have some fun. Don't really listen to what I'm suggesting here. And then the more you crank it up, that's actually how it was explained to me. And the more you crank it up to 15, don't go too high. Things start to fall apart. But 15 was pay attention to this rigidly. So this was, you're watching in real time. This is me responding to this new sampling method. PLMS wasn't working last time I tried this model, even though it's version 2. This is what I was expecting when I ran the other one. PLS doesn't work with this model. It was trained on, oh my God, it does work. I'm going to have to edit this.